Hello everyone, I am Dr. M.K. Deore. Friends, in the previous lecture, now we have seen about the active medium and the condition for the light amplification. And today in this lecture, we are going to see about the different methods of achieving the population inversion and the different pumping schemes. Friends, now we are going to see in details about the methods of achieving the population inversion. In the first chapter, we have seen about what do you mean by the population inversion. We know that under the normal conditions, more electrons are in the lower energy state than in the higher energy state. And the population inversion is the process of achieving the more electrons in the higher energy state than in the lower energy state. Now in these two figures we can see here, in the first figure, which is at the normal population, in which here the number of atoms are in the lower energy state are greater than the number of atoms in the higher energy state. But after the population inversion, the number of atoms in the higher energy state are more than the number of the atoms which are in the lower energy state. Now that means here the population inversion can be achieved with the help of some external systems or the external process, and that process is known as the pumping process. So the pumping is the process of achieving the population inversion. That is the process in which or the process which rises the atoms from lower energy state to the higher energy state in the active medium. So to achieve the population inversion, it needs the pumping process. The process of supplying the energy to the lesser medium is called the pumping. Now then, what do you mean by that, or what happens in a pumping process? The process of supplying the energy to the lesser medium is called the pumping, and the source that supplies the energy to the lesser medium is called the pumping sources. Is called the pumping source. Now in order to achieve the population inversion, we need to supply the energy to the lesser medium by using the different types of the pumping source. The type of the pump source is depends upon the laser mediums. That means here for the different types of the laser mediums, the different types of the pumping source are used. That means the different pump source are used for the different laser mediums to achieve the population inversion. Now here we are going to see the most commonly used pumping sources, which are as follows. The first one is the optical pumping, second one is the electrical pumping, and third one is the chemical reactions. The fourth one is the direct conversion. Now then, the students, we are going to see in details about these are different types of the pumping sources or the different types of the pumping methods here. The first one is the optical pumping. Now we know that the optics is nothing but the rays of the light. So in optical pumping, as the name suggests, in this method light is used to supply the energy to the laser medium. Now in this diagram, we can see here this is the one type of the laser which is known as the ruby laser, in which the ruby rod is used here the active medium. And around this ruby rod, now we can see here this is the spiral tube, and this spiral tube is known as a flash tube. Now here an external light source like such a type of the flash discharge is used to produce the more electrons in the higher energy level of the laser medium. So with the help of a discharge tube, now generally the xenon flash lamps are used as for the optical pumping. Now when this flash tube emits the radiation, and when these radiations interact with the active medium, then the atoms in that active medium gains the energy, and these atoms goes from lower energy state to the higher energy state. That means when a light source provides the enough energy to the lower energy state, electrons or the atoms in the laser medium, they jump to the higher energy state here. And in this way, in that active medium, the condition of the population inversion will be achieved here. So, in this way, by using such a type of the optical pumping, we can achieve a population inversion in an active medium. Now, such a type of the optical pumping is mostly used in a solid state type of the lasers. The second type of the pumping is the electrical pumping. Now it is also known as the electrical discharge or the excitation by the electrons. Now here the electrical discharge refers to the flow of electrons or the electric current through a gas. So in this method of the pumping, the electrical discharge acts as the pumping source or the energy source. Now in this figure we can see here, this is the one of the type of the laser which is known as the helium neon laser or the gas laser. Now it consists of this is the discharge tube in which a mixture of helium and the neon gas is inserted there. This discharge tube consists of two discharge electrodes here. When a high voltage electric discharge is passed through a laser medium or through a gas, and the intense electric field accelerates the electrons to the high speed and they collide with the neutral atoms in the gas. As a result, the electrons in the lower energy state gains the sufficient energy from the external electrons and jumps into the higher energy state. Now that means simply we can say that when we apply a sufficient voltage across these electrodes, so it produces the intense electric field, and this intense electric field accelerates the electrons with the high speed, and these electrons collides with the neutral atoms in that gas medium, and as a result the electrons gains the energy, and these electrons goes from the lower energy state to the excited energy state. In this way, with the help of the electrical pumping or the electrical discharge, During the collision of the electrons, accelerated electrons and the atoms, neutral atoms of the gas, there is the excitation. Now such a type of the pumping method is used in a gas type of the laser. So the students remember about that how the electrical pumping is used to achieve the population inversion and where such a type of that the electrical pumpings are used. Mostly such a type of that the electrical pumping is or the electrical discharge or the electrical pumping is used in a gas type of the lasers. The next one is the thermal type of that the pumping. Now we know that sometimes we can achieve the population inversion by heating the laser medium. In a thermal pumping methods, heat acts as a pumping source or the energy source, and in this method the population inversion is achieved by supplying the heat into the laser medium. That means when the heat energy is supplied to the laser medium, the lower energy state electrons gain the sufficient energy and jumps into the higher energy level. That means in this process, or the process of achieving the population inversion in a thermal pumping is almost similar to the optical pumping or the electrical discharge method. Now except that in this method the heat is used as a pump source instead of the light or the electric discharge. Now in the previous method, those we have seen in optical pumping and the electrical pumping. Now in optical pumping, the light is used as an energy source, and in the electrical pumping, the electrical discharge is used as an energy source. But in a thermal pumping, the heat energy is used as a pumping source, and with the help of that the thermal pumping, the heat is directly given to the laser medium, and in this way when the atoms which are in the ground state gains the energy and goes from the lower energy state to the higher energy state and achieve the population inversion. So generally the thermal type of the pumping is also used in a solid state type of the lasers. The next one is the chemical type of the pumping or the chemical reactions. Through the chemical reactions, in a chemical type of the lasers, the population inversion can be achieved. If an atom or the molecule is produced through some chemical reactions and it remains in the excited state at the time of the production, then it can be used as for the pumping here. Now take one of the example how the chemical reaction is used as a pumping source. Take an example here, the hydrogen fluoride molecules is produced is an excited state when the hydrogen and the chlorine gas chemically combine with each other. The number of the produced excited atoms or the molecule is greater than the number of the normal state atoms or the molecules, and thus the population inversion is achieved there. Now with the help of these chemical reactions, we can easily understand when the hydrogen and the chlorine molecules are chemically combined with each other to produce the hydrogen fluoride molecules, and this hydrogen fluoride molecule will be stay in the excited state. So through this chemical reaction, this hydrogen fluoride molecule stay in the excited state and in this way here, through that chemical reaction, we can achieve the population inversion. So now in this way here, such a type of the pumping method, that is the chemical reactions, is used in a chemical type of the lasers. The last one is the direct type of the conversion. The direct type of the conversion method is used in a semiconductor type of the lasers. Now students, you have already studied about the semiconductor in the 12th standard also and in the T.Y.B.Sc also. How there is the flow of the current in a semiconductor? We know that the flow of the current in a semiconductor is due to the some type of the carriers are known as the electrons and the holes. Now in a semiconductor laser, such a type of the pumping is used. Now but here it is not the atoms that are in the excited state. Now in this case here, in a electrical type, now we have seen in electrical type of the pumping, the atoms goes to the excited state. But here the atoms are not goes to the excited state. Now here is the current flowing, and the current is namely due to the electrons and the holes which are in the excited state here. So here it is the current carriers, namely the electrons and the holes which are the excited state, and the population inversion is achieved in the junction region. Now we know about the p-n junctions also, and the electrons recombine with the holes in that junction region, producing the laser light here. So here during the recombination of the electrons and the holes, there is the generation of the light, and that light is nothing but the laser light. Thus the semiconductor laser is a direct conversion of the electrical energy in the light energy takes place, and in this way we can say that the direct type of the conversion pumping method is used in a semiconductor type of that laser. So the students, now we have seen the different type of the pumping methods, and these different types of the pumping methods are useful in a different types of the laser types, different types of that laser, but that are depends upon the which type of the active medium is used in that laser medium. So remember what are the different types of the pumping methods or the pumping sources and how they are used in the different types of the lasers here. Now students, here we are going to see in details about the pumping schemes. Now students, we have seen the energy in a first chapter about the energy levels and how they are the formation of the energy levels in the atoms and in a solid materials also. We know that the atoms in general characterized by the large number of the energy levels. Among these energy levels, now there are the 2, 3 or the 4 levels will be applicable to the pumping process. So for the pumping process, generally the 2 level, 3 level and the 4 level scheme pumping levels, energy levels are used for the pumping process. But the pumping these pumping, according to that, the pumping schemes are classified as a 2 level pumping scheme, 3 level pumping scheme and the 4 level pumping scheme. But among these, the 2 level pumping scheme will not be lead to the laser action, and so mostly the 3 level and the 4 level pumping schemes are very important and widely used to explain the action of a different type of the laser. So the students, we are going to see in details about the 3-level pumping scheme and the 4-level pumping scheme. Now the first one is the 3-level pumping scheme. Now this is the schematic diagram of the 3-level pumping scheme. Now we see here the different energy levels. Now consider a system consisting of the different energy levels, say as the E1, E2 and the E3, and with it consists of the n number of the atoms. Now we assume that the energy level such as the E1 is less than the E2 is less than the E3. Now that means the energy level E2 lies in between the energy level E1 and the E3. The energy level E1 is known as the ground state or the lower energy state, and the energy level E2 and the E3 are known as the excited state. But among these, the energy level E2 is sometimes referred as the metastable state, and the energy level E3 is sometimes referred as to a pumping state or the pumping level. So remember about which one is the metastable state, which one is the ground state, and which one is the excited state level in the 3-level pumping scheme. Now let us consider here N1 be the number of the atoms in the energy state E1, N2 be the number of the atoms in the energy state E2, and N3 be the number of the atoms in the energy state E3. Now to get the laser emission or the population inversion, the population of the higher energy state E2 should be greater than the population of the lower energy state E1. That means it should satisfy the condition N2 should be greater than the N1. That means here the number of the atoms in the energy state E2 should be greater than the number of the atoms in the energy state E1. Now we know that under the normal condition in a 3-level energy system, the 3-level or the lower energy state E1 is highly populated as compared to the excited state and excited energy state E2 and the E3. That means we can write here the N1 at the normal under the normal condition, N1 is always greater than the N2 is always greater than N3. But under certain conditions, the greater population of the higher energy state E2 as compared to the lower energy state E1 is achieved here, and such arrangement is called the population inversion. That means with the help of the external pumping method, we can achieve the population inversion in between the E2 and the E1. Now when we supply the light energy, that means the incident radiations, when interact with the atoms which are in the ground state energy, then the light energy which is equal to the energy difference between the E3 and the E1, then when the energy of the incident radiations becomes equal to the energy difference between the energy levels E1 and the E3, then the atoms which are in the ground state energy gains the sufficient energy and jump into the higher energy state E3. Now this process of supplying the energy is called the pumping, and the flow of the atoms from E1 to the E3 is called the pumping transition. So remember, now where is the pumping transition? That means in the level between the level E1 and the level E3, there is the pumping transition. Now we know that the lifetime of the energy state E3 is very small as compared to the lifetime of the electrons in the energy state E2. Therefore, the atoms in the energy level E3 does not stay for a long period, and after the short period, they quickly fall to the metastable state or the energy state E2 and release the radiation, less energy instead of that of photon. That means due to the short interval of the time, the atoms which are in the excited state goes to the lower energy state, which is known as the metastable state. And during this transition, it emits the radiation which is the non-radiative transition. That means during this transition, there is the non-radiative transition, means it emits the radiation which is in the form of heat. Because of the short lifetime, only a small number of the atoms accumulate in the energy state E3 here. During the transition from the level E3, some of the excited atoms make the spontaneous transition to directly the ground state. Here means some of the atoms goes directly to the ground state energy, and most of the atoms or many of the atoms undergoes the spontaneous non-radiative transition to the metastable state E2 here, and which is a non-radiative type of the transition. The atoms in the metastable state E2 will remains there for a long period because it's longer lifetime. We have already seen in a metastable state, the atoms in the metastable state having a longer period or the long lifetime. As a result, the large number of the atoms start accumulate in the metastable state. Thus, the population of the metastable state will becomes greater than the population of the energy state E3 and E1. That is, we can say that the N2 is greater than N1 and is greater than the N3. Thus, in a three-level energy system, the population inversion is in between the energy level E1 and the E2. Now, when the incident photon interacts with the atoms in the metastable state E2, then it forces that atoms to fall back to the ground state here, and as a result, the two photons are emitted, and this process of the emission of the photons is called the stimulated emission. Now, that means when the incident radiations having the energy, say at the having the energy equal to the photon. Now, when the one photon interacts with the one atoms in the metastable state, it emits the two photons, and these two photons forces again the two atoms in the metastable state to fall back to the ground state and emitting the four photons here. Now, in this way, as a result, a large number of the photons are emitted, and we can say that there is the amplification of the stimulated emission, and it emits the laser beam. So, the emitted laser beam during the transition from the metastable state to the ground state, and that transition is also known as the laser transition. So, the students, you have to be remember here how the three-level pumping scheme works here, and where the population inversion achieved and where is the stimulated emission achieved, and during which transition there is or it emits the laser transition or it emits the laser radiation. So, remember about its the schematic diagram also, and the operation of the three type of the three-level laser scheme. Now then, there is one of the drawback of the three-level pumping scheme. In a three-level laser system, the terminal level is the ground level, and hence more than half of the atoms are to be transferred to the higher energy level. In this three-level pumping scheme, the population inversion is achieved in between the metastable state and the ground state. So here, the ground state level is acts as a terminal level. Now but we know that as the ground state is heavily doped and the large number of the power is to be used to depollute the ground level to the required extent. For the deep pollute the ground state, we need more than half of the atoms are to be transferred to the higher energy level. That means with the help of the suitable pumping method, it needs to pump more than half of the atoms to be transferred from the ground state to the higher energy level. Then and then it will maintain the population inversion in between the metastable state and the ground state energy. And for that, it needs the high pumping power. So this is one of the major drawback of the three-level pumping scheme. To maintain the population inversion, it requires the high pumping powers, and due to that, its efficiency will also be decreases. Now then, which type of the output will be generated from the three-level pumping scheme? Now the three-level pumping scheme generates or produces the light which is in the pulses form. Why? Now see here, once the stimulated emission commences, the metastable state E2 gets depolluted very rapidly and the population of the ground state increases quickly. As a result, the population inversion will be end. Now that means here, when or during the transition from the metastable state to the ground state, the more number of the atoms will be accumulated at the ground state and the number of the atoms becomes greater or becomes more as compared to the metastable state, and hence the population inversion will end there. Therefore, with the help of the suitable pumping method, again it needs to transfer more than the 50% of the atoms from ground state to the higher energy state. Then and then the population inversion will be achieved there. So it takes some time to maintain again the population inversion. So one has to wait till the population inversion is again established, and thus the three-level laser operates in a pulse. So due to that here, it produces the output in a pulsating mode. So remember why the three-level pumping scheme produces the output in a pulses form. Now then we are going to see in details about the four-level pumping scheme. Now this is the schematic diagram of the four-level pumping scheme. Now it consists of the four energy levels. Now consider a system consisting of a four energy levels E1, E2, E3 and the E4, which they contain the n number of the atoms. Now here we assume that the energy level E1 is less than the E2, is less than the E3, is less than the E4. That means the energy level E3 lies in between the E2 and the E4. So here the energy level E1 is known as the ground state or the lower energy state, and the energy level E3 and the E4 are known as the excited state. We know that the energy level E3 is sometimes referred to as the metastable state, while the energy level E4 is sometimes referred to as a pumping state or the pumping level. The number of atoms in the lower energy state or the ground state is given by the N1. The number of atoms in the energy state E2 is given by the N2. The number of the atoms in the energy state E3 is given by the L3, and the number of the atoms in the energy state E4 is given by the L. We know that the lifetime of the atoms in the energy state E4 and the energy state E2 is very less. Therefore, atoms in these two states will only stay for a short period because its lifetime is very short. Now, when we supply the light energy, which is equal to the energy difference between the E4 and the E1, then the atoms which are in the ground state or the lower energy state gain the sufficient energy and jump into the higher energy state, say as the E4. Now, but we know that the lifetime of the atoms in the higher energy state E4 is very small. Therefore, after a short period, they fall back to the next lower energy state E3 by releasing the non-radiative transition. That means when the electrons or when the atoms goes from the excited state to the metastable state, there is the non-radiative type of the transition, and it radiates the energy, that means here, but non-radiative transition, and which is in the form of the heat also. Now we know that the lifetime of the atoms in the energy state E3 is very large as compared to the E4 and the E2. That means here the lifetime of the metastable state is large as compared to the excited state E4 and the lower energy state E2. Now after completion of their lifetime, the atoms, that means here, as a result, the large number of the atoms start to be accumulate in the energy level E3 here, because the lifetime of the metastable state is large, and due to that, now there is the accumulation of the large number of the atoms in the energy level E3. Now after completion of their lifetime, the atoms in the energy state E3 will fall back into the next lower energy state E2 by releasing the energy in the form of the photons. Now here, similar to the energy state E4, the lifetime of the electrons in the energy state E2 is also the very small, and therefore the atoms in the energy state E2 will be quickly fall into the next lower energy state of the ground state E1 by releasing the non-radiative transition. That means when the atoms goes from the energy level E2 to the E1, now there is the transition, and which is also the non-radiative transition. Thus, we can say that the population inversion is achieved between the energy state E3 and the E2 here. Now here, when the incident photons interact with the atoms in the metastable state E3, then it forces that atoms to fall back to the ground state here. And as a result, the two photons are emitted, and this process of the emission of the photons is called the stimulated emission. So during the transition from E3 to the E2, now there is the stimulated emission. Now when the one photons interact with the one atoms in the metastable state, it emits the two photons. These two photons forces the two atoms of the metastable state to fall back to the ground state and emitting the four atoms. Now in this way we observe that there is a large number of the photons are emitted, and we can say that there is the amplification of the stimulated emission. And in this way, during this transition, a laser beam will be the emitted here. So the students in a core level pumping scheme, remember that where is the formation of the population inversion, and also during in which transition there is the stimulated emission will be achieved. So remember about the basic, the schematic diagram of the four level pumping scheme, and according to that, the energy level diagram, how we can explain the working of a four level pumping scheme. Now similar to that, the three level pumping scheme. Now we have seen one of the drawback of the three level pumping scheme, but here is one of the advantages of the per level pumping scheme. In a four level scheme, the lower laser transition level is not the ground state and is virtually vacant. That means here the lower transition level, that is the ground state level, is not acts as a terminal level. Here in a four level pumping scheme, the E2 is acts as a terminal level. To create the population inversion, there is no need to pump more than the 50% of the atoms to the upper laser levels. Now, we have seen that in a four level pumping scheme, the population inversion is achieved in between the level E2 and the E3. And that means here the E2 acts as a terminal level, and due to that, here no need to create the population inversion in between the level E3 and E1 here, because E2 acts as a terminal level. That means there is no need to pump more than the 50% of the atoms to the upper energy level from the ground state energy level. And this is one of the advantages of the four level pumping scheme, in which it requires the less pumping energy as compared to the three level laser scheme. So remember, the main advantages of the four level pumping scheme is that it requires very low pumping energy to transfer the atoms which are in the ground state energy to the excited state energy, as compared to the three level pumping scheme. Now then, which type of the output will be generated from the four level pumping scheme? The lifetime, we know that the lifetime of the lower laser transition level E2 is much shorter, as it is not a metastatic state. Hence, the atoms in the level E2 quickly drop to the ground state. Now, this steady depletion of the E2 level helps to sustain the population inversion by avoiding an accumulation of the atoms in the lower lasing level. Now, that means here we have seen the population inversion in a four level pumping scheme is achieved in between the two energy levels E2 and the E3, because there is a very fast transition from the level E2 to the E1, and hence no accumulation of the atoms in the lower lacing level. So the lacing action is occur in between the level E2 and the E3. Therefore, it maintains the population inversion, and due to that it produces a continuous emission of the laser radiations. Therefore, the 4-level laser can operate in a continuous wave mode. Now we have seen in case of that the 3-level pumping scheme. Now it produces the output which is in a pulsating mode, but here we observe that the output of the 4-level pumping scheme is in a continuous wave mode because in a lacing level it maintains the continuously a population inversion. So the students, in this lecture we have seen the different methods of the achieving the population inversion and also the two pumping scheme such as the 3-level pumping scheme and the 4-level pumping scheme. So you have to be remembering the working the schematic diagram of these pumping scheme, their working of the pumping scheme according to the energy levels, the drawback and the advantages of the pumping scheme, and also the different methods of the pumpings and how they works and where these pumping methods are suitable for the different types of the lasers here.